Hey, looks like there's somebody already here. We'll get started in just a minute. I'm going to set a few things up first. Hey, good morning. Welcome. We're going to get started in just a minute here. I'll wait a few minutes for folks to show up. All right. Cool. So let's get started. Welcome, everybody. I see we've got about 8 people. And I think we're ready to start. Cool. Thanks for coming. I was really excited to give this presentation because I get a lot of the time people come to me and say like, oh, why can't GitLab or Rouge support my favorite language? Or even more common is people opening issues on the Rouge project being like, I would love to submit a lecture for this language, but I don't know Ruby. So we're gonna get past a little bit of that and explore Rouge, and hopefully by the end you will feel confident enough to try your hand at a lecture. Does that sound good to everybody? So if you haven't used BlueJeans before, there's a little chat window. It should be 2 buttons underneath your the video feed of yourself. And you can type in there, and I will try and keep an eye on that and answer questions as they come up. First thing I would like you to type in the chat window is, can you see my screen? Is everybody great? Cool. The next thing is this about the right size for you to see in my terminal here? good? Okay, cool. This is Rouge. It's a syntax highlighting gem. This is what we're going to be looking at today. This is the gem that is used by GitLab to highlight everything that we highlight. And it supports a bunch of languages. And we're going to go through sort of how it works. We're going to mess around with it in the REPL. And then we're going to sit down and make a new Lexer. All right. So that's three things that we're going to do. First is we're going to do a walkthrough of the architecture and sort of what pieces constitute a syntax highlighter and how it sort of works. We're going to look through the debug output from a Lexer. A Lexer being what adds language support to Rouge. And then we're going to add support for a language and walk through what the workflow is for that. So that you can do that sort of as quickly and as efficiently as you like. So let's start with the architecture. So here is a clone of Rouge. I've checked out a branch so that we can do Git stuff and not sort of worry about messing with master, which you should also do if you're adding a language. But it's a typical Ruby gem layout. If you want to follow along, I recommend you do so. Just clone Rouge, and you should be able to do all of this stuff. And I apologize about background noise. There's some neighbors apparently doing some tree work. If you want to follow along, I suggest you do so. It is at the project is unfortunately at GitHub, not GitLab. But I suggest you clone it and follow along. So the first thing I'm going to do is start an IRB session, which I add the lib path to include. So we have our sort of local, we can require stuff locally, and then I'm going to require Rouge. Cool. So now we have an IRB session with Rouge in it. And actually, I'm going to do slightly different than this. There's a slightly easier to use REPL called pry that I'm going to be using. Okay. So Rouge is split into 4 parts. The first part that I want to talk about are Lexers. And those are in the Rouge Lexers namespace. So if we look at, for example, Ruby, we can you can either use an instance or the class itself, and they have a method on them called lex. And they don't do a whole lot of work if you just call them. The point of a lexer is to turn a string that you're going to be highlighting into a stream of tokens. So this is a lazy enumerator. So in Ruby, you can force a lazy enumerator to be an array by calling .2a on it. And we see we have transformed this into a stream of tokens, right? It recognizes that there's a name, there's text, which is sort of the token that means don't highlight this at all, which we don't usually highlight texts. We've got an operator, and we've got another name. All right, so this piece of Rouge doesn't make any decisions about what colors to highlight things as. It just sort of says abstractly, these are the parts of the thing. And again, these tokens are generated lazily. We sort of walk through the string. Whenever you ask for the next token, it'll do some analysis and try and figure out what the next one is. These tokens actually are stored over here in token.rb. There's a little bit of meta programming, but when you get down to here, you can see the list of tokens. They are, interestingly, completely stolen from Pigments, which is the similar Python library. And the reason for that is not just a lack of creativity, but actually we can, because we've stolen exactly the tokens from pigments, we can output HTML that will be correctly highlighted if you have a style sheet that was designed for pigments. So if you want to switch from pigments.rb to Rouge, it should be pretty straightforward. We don't necessarily support all of the languages that Pigments does, and at last I checked, we supported a few more than they do, but they might have caught up at this point. So I'm going to pause for questions. Does all this make sense to you? We've got Elixir. It makes us a lazy stream of tokens. Here are the tokens. We've got names. You can type your questions into chat if you like, and I will try and answer them. All good? Okay. The next part of tokens is the short name. The short name here, and you can see every token has a short name, and these are actually what the class names that we use in the generated HTML are. So we'll be seeing those in just a second. The next important part of Rouge is formatters. A common one will be HTML. We also have terminal 256. And I'm using terminal 256 to kind of just show you. So Rouge Elixir's ruby.new. So we got Elixir in a formatter, and we can grab a lazy stream of tokens from Elixir, as we saw. There's a lazy stream of tokens, and the formatter's job is to format that as something. So we pass it the lazy stream of tokens. We'll get, well, in the terminal 256 case, we'll get some gobbledygook. But if we actually just print that to the screen, you see that gobbledygook is actually ANSI escapes that will give us some nice highlighted code. If we instead use Rouge formatters HTML, we will get an HTML. And you can see that there's some nice classes in there that come from the token. So we've put a span around every token and have put it in a class. And with the bare HTML formatter, you're responsible for putting it in a pre-block and all of that fun stuff. So you can do sort of whatever you want with it. There are a couple of other things that you can do, other kinds of HTML generation. There's HTML inline, which actually expects a theme, which I will get to in a second. That is the next part of the 4 parts of Rouge. Plural. So with the HTML inline formatter, instead of using class names, you'll get just actual colors and styles inlined into the style attribute. And this is intended for platforms like email, or if you, for some reason, can't add CSS to somewhere. Cool. There we provide a couple others, like one that does line numbers, etc. But can look into that as you like as a user of Rouge. The next bit of Rouge is themes. Which are just responsible for generating some CSS. And there's a nice little syntax. You can set up your palette and then style various tokens as different things. So that's what a theme is. Relatively straightforward. Everybody with me? Awesome. And the last bit of Rouge is guessers, and these are responsible for trying to figure out what language a thing is. So, and this is about to get a little bit of an overhaul, so I don't want to go into too much detail. The easiest way to use it from the outside, this is sort of an implementation detail, the easiest way to use it from the outside is rouge lexer.guess. You can pass it things such as file name. So if you have a .rb file, we know that it's Ruby. If we don't know anything, we'll tell you that it's plain text. Source has a in bash in it. We'll tell you that it's shell. And a couple other nifty widgets. Recently we added support for mode lines, both Vim and Emacs style. So if you just sort of put mode lines in your file, it will it'll highlight correctly. And the thing that I want to underscore about guessing is that it's an incredibly imperfect process, and there's actually no way to do it 100% correctly all the time. My favorite is .pl, the extension .pl, which I believe we tell you that it's ambiguous. For example, because this extension is used both for Perl and Prolog. So it's hard to say. But this is one of the places where we're gonna improve this in a near coming version of Rouge. We're gonna have some fun special case heuristics to try and figure this out. But if you're a GitLab user, you can actually override the choice of language through a git attributes flag, and I can link you to documentation if that's useful. Cool, so that's the 4 parts. There's lectures, create a stream of tokens, formatters, which take that stream of tokens and output text, themes, which are responsible for outputting CSS and generally figuring out how to style things, and guessers, which are responsible for trying to figure out what language a piece of text is in. Cool. Y'all with me? The 4 bits of Rouge, how they relate to each other?
Can I ask real quick?
Yeah.
When at least in GitLab, when the guesser cannot choose what's the language, what does it do? It does no highlighting?
I forget exactly. I think in this case it'll just pick Perl. But certainly we don't just crash.
Right.
Yeah. In the worst case, we'll highlight it as plain text, and just not give you any highlighting. But again, we're going to be getting better at this in a soon to come version of Rouge. I have a big old diff on my laptop that should help. Does that answer your question?
Yes.
Okay, cool. And you notice that the error this raised is not actually possible to catch because, or anyway, this is a bug right now because it's fun. But moving on from that, we're going to do a deep dive into a lexer. All right, so lexers have options. You can control sometimes these are user facing and sometimes they are a little bit more for us. So let's look at a lexer. I'm going to look at the HTML lexer. So this is responsible for figuring out for lexing the some text formatted in HTML. So Rouge lexers, actually formatter lexer is Rouge lexers HTML dot. And if I say lexer.lex if class equals hello world if so, and we've got to force it with 2a. There we go. So we see we've got a name.tag token, a name attribute token, etc., etc. Cool. So let's look a little bit into how this does it. So the HTML lexer and all lexers take a keyword argument called debug, an optional keyword argument, and it can be any truthy value. I use 1 because that's what's used. We'll see that later. So there's debug, and that'll print a lot of stuff to standard out. So let's wrong thing. So that printed a lot of stuff to standard out, and still returned the same thing. So the debug flag just says print a bunch of stuff to standard out about what you're doing. So let's go through how the lexer makes tokens. Yes. So I want you to look at the right side, and you can see a bunch of these little chunks of sort of dedented to indented bits. So what these are is this is one tick of the lexer. The lexer is you can think of it as just kind of a loop that tries to find the next token over and over again. So what do we got? So our lexer is HTML. We have a stack of some sort. We've got the stream, and this is sort of a truncated version of the input. And we can see it tries a bunch of different rules, which are regexes. So it's looking for a bunch of different things. It's not finding any of them until it gets to here. And this regex matches at the head of the stream. And we see that it matches this bit of text. This rule says we yield a name tag, and we push a state. Are you with me so far? Try a bunch of rules, we get a rule, and we do some stuff, and then we go to the next step. I want to make sure you're with me here. Okay. Cool. the rules, as you can see if you're looking at the left side of my screen, come from the lexer. So we see here a state declaration. We're defining the state root, and that is that should map you to here. So in the state root, we have a bunch of these rules, and the one that sort of got activated it can have a pretty large speed improvement. Because obviously this will get tried every tick. It's a little bit tricky because sometimes when you put a rule later, generally I like to put the most specific things at the top and the most general things at the bottom, since the rules get tried in order. But we'll go into that in a minute. But yes, you're right. The order that the rules are in can have a major effect on performance. Okay. And that is something to think about. Okay. So the rule that was activated here is this one, where we match looking for a thing that looks like a tag, and use the name tag token and push the state tag. Now, what is pushing a state mean? Go into that real quick. So we see in the next tick we have another thing on our stack because we've pushed tag to our stack, and what that means is the bag of rules it's gonna try are in the tag. So the way a tick works is it takes the state on top of the stack and tries its rules only. Cool. And I'll get to what happens if you run out of rules in a second. So now we're in the tag state, and we hit a match on our first regex, which is just white space, and we just say that's text, and that's fine. We're still in the tag state, and we're going to be here until we decide we're not. So in the tag state, we find this sort of attribute-looking thing. That would be the second rule here. And so the tag state, by the way, is just a way of saying we're inside a tag right now as we're lexing, right? We're in the div tag. We haven't closed it yet, and this might be a place where we would find attributes, right? Where outside of a tag, you're not going to highlight attributes necessarily. So that's sort of what the state stack is for. Is it allows you to sort of maintain a sense of context throughout the lex. Right, so we find this thing that looks like an attribute. We highlight it as name.attribute, and then we push another state. With me so far? Pushing states is a major part of lexing, so I want to make sure this really sinks in. We've got this attribute state here as well, which says here's where we expect an attribute value to go, and you can see kind of how the sort of natural nesting of the language sort of is revealed in the state stack that we actually use. So we have root, which is just where we see HTML. We have tags, which is inside tags, and then we have attributes that are inside a particular space within a tag. Cool. All right, so we've got attribute, which does some special handling for different kinds of strings and also for bare words, which are a thing that happens in HTML. And we see the double quoted string hello. In fact, we do one better. we use go to here instead of push. So let me remark on this syntax here. So this syntax where you just say rule regex token state name, and then it pushes that state, that's sugar. For the sort of full syntax, which is the, and I can actually show you that it is sugar if I go to regex lexer b. And this file is very ugly, but it's ugly for a reason, which is that it's incredibly tightly optimized. Like, we spent a lot of time on this and decided that it was okay for it to be ugly because it needed to be fast. This was a design decision, and it still allows the lexers to be pretty themselves, which is what has the most charm. And you can see that, like, in this rule method here, which is what we're calling here, we actually just make a proc to use as the, so the block is sort of the full syntax. And what it can do is it can yield tokens. First of all, there's a bit we're not using here where it'll send you the match. And you can say, M0 for the whole match. That, in this case, it'll just be a single quote, right? The token method defaults to the whole match. So here we're just saying yield the whole match as a string token. And you can do things like pop. You can do things like push another state. You can push more than one state if you want. A billion copies of the same state if you're feeling up for it. Whatever you like. Go to is a sort of sugar for pop and then push this state. So replace the top of the stack with this other state. So you can see in HTML land, we see a double quote, and we're like, okay, well, we're not in attribute state anymore. Instead, we are going to be in double quote state where we're scanning for a matching double quote. In this case, we probably could have done this double quote stuff with a single regex. We probably could have just said rule star question. Okay. There is one advantage to using a separate state. Does this make sense that you could have done it with a single regex? This here star question is a non-greedy match, so it'll match dot star anything until it sees a double quote, and not sort of just take over your entire string and find the last double quote in the thing. Non-greedy matches are very, very useful in regex. In the regexes for lexers, because 99% of the time you want to scan until a thing rather than match the whole thing. So the advantage to using a block is that, for example, we haven't done so here, but we could, for example, do escapes and highlight those in sort of within strings, if that makes sense. So we have a little bit more control if we use a state. We didn't actually do that here, but potentially we should. Oh, and you can see I left myself a nice note asking whether \escapes are valid in HTML, which we could go back and look at some point. And we got a similar thing for single quote. Okay, so that's that. And you can see once it finds this matching double quote, it pops back, and that happens right here. We find the matching double quote, we pop the stack, and then we're back just in the tag context. And in tag, we see the closing angle bracket. And we say that's part of the name.tag token, so it's highlighted the same as the open one, and we also pop the stack, so now we're no longer in a tag, right? Which is correct, because now we're actually just in HTML context, in the root HTML context. We find world, it's text, and then we actually, in HTML, we match closing tags with a single regex, and don't push any state. Does that make sense? So in HTML, we're not, a common question to come up is like, well, what if somebody, misnests tags, right? Like, what if someone does like that, right? And we just highlight that the same. And the more I work on syntax highlighters, the more it becomes clear that catching errors isn't really our job here. And this is a little bit of a philosophical thing, but our job is to take correct code and highlight it correctly. So it's way more important to me to be fast and to highlight correct code correctly than to catch every possible error that could come up. Cool. And keeping a stack of tags that have to be closed correctly and whatever is just going to be a nightmare. We've learned that lesson in Python, where we decided to try and only have the from keyword allowed in particular contexts, and then the Python folks decided that from in Python 3 is going to be used for 1,500 different other things, and we're still trying to fix that, actually. So, lesson learned. In Lexers, just be flexible. Are y'all with me now? That is the end of that segment where we walk through the debug output of a Lexer. Cool. Oh, I'm actually going to show you one more thing, which is how we handle errors. So, for example, let's a much smaller example. Let's look at something that is just not valid HTML. Okay. Oh, thank you. Yeah, it's the Lexer DSL is the product of trying to highlight a lot of different languages with the same kind of machinery and finding out a lot of things didn't work and finally come to something that works pretty well. So this is not valid HTML, obviously, and we don't actually have rules to handle this. And this is another difference between highlighting between lexing for highlighting and lexing for just implementing a language. If you've ever done parsing for a language implementation, in a language implementation, you would just throw an error here. Just say, nah, that's bad. We're not going to do anything anymore. But in Rouge, we're a syntax highlighter, so it's likelier that someone just has some garbage in their file and has some perfectly valid stuff afterwards, right? So we go to great lengths to try and recover from this sort of thing. And in this case, we have these error tokens. So instead of just failing and saying this is invalid input and we're done, we yield an error token. And there's 3 ways that an error token can happen. The most common way is what we're seeing here, and that is, we go up to where that happened, is if you run out of rules. When we're in root here and we run out of rules, so nothing here matches. It tries everything and nothing matches. The behavior is to move the stream forward by 1 character and yield an error token with that character. So basically what we do is we say, nothing matched here. I'm assuming that this next character that we're seeing is garbage or something weird, and we're going to move forward one character and try again. And we keep doing that until something matches, right? So here we do it again. Now, you may be asking yourself whether this is going to result in a bajillion single character tokens, which you would be right. It does result in a bajillion single character tokens, in this case, 2 single character tokens. However, we have some code that in the background consolidates consecutive tokens of the same type. So if you yield an error token 5 times, you're going to end up with a single error token that is 5 characters long. Cool. So it sort of works itself out. And in fact, that's what you see here. You see at the end of the day, we have a single error token, which is 2 characters long. The next way that an error token can be yielded is you can actually just do it yourself. You can say, if anybody tries to do this, it's an error, right? This is a little bit less common, but sometimes there's special cases where you know that a thing is an error and you need to do some sort of manual recovery, and that works for that. And the last one is a little bit odd, and this happens a lot if you make typos in a lexer. So when a rule actually successfully matches, it has a particular length that is matched. And when it's done matching, the stream moves forward that length, right? So you consume that part of the input. It is possible and often happens that a regex will match an empty string. This sometimes happens when people say rule any number of word characters, right? And this is bad news. Let's say that's a variable. This is bad news because this will happily match the empty string. This will match 100% of the time. And in fact, whatever, I'm not going to reload. But what's going to happen here, let's reload. Is we're going to get a bunch of error tokens all over the place. Meow. And you'll see this message in the debug. Too many scans without consuming the string. So we actually recover from this pretty nicely as well, in that you can actually only scan 5 times. You can only go through 5 ticks without advancing the stream. And the reason that we allow you to do it up to 5 times is that sometimes we use empty regex as default. So you'll sometimes see this at the bottom of rule sets, where if you don't see anything that we like, just pop the stack and move on to the next thing. But if you just sort of are sitting there churning, the system will sort of recover from that in a pretty elegant way by just saying, okay, we're stuck here. We're just going to move forward one character and have it be an error token. And we'll just keep moving forward until something matches. And this, when this happens, it's very slow. This is sort of a safety net and should not be used for actual features. That should be obvious, I suppose. But so that's the third way you can get error tokens, is by having empty matches everywhere. Cool. Feel good about the error tokens? Okay, so now I'm going to exit this REPL, and we are going to make ourselves a Lexer. And I'm going to show you what sort of the workflow for developing one of these things is. It's one thing to kind of look at this and see, oh, well, someone just sort of made all of the things, and etc. Oh, sorry, one more thing here. Oh, gosh. I didn't show you. Is this fun feature. It is quite common for languages to include other languages, and HTML is definitely one of them. Like so. Of course, you can have JavaScript in HTML, and we want to highlight that as well. And the way we do that is with this delegate keyword, which just says this thing to Lex what we just matched, and yield out the tokens that it gives us. And you can kind of see here in the debug output that we're delegating to JavaScript, et cetera. And yeah, so that's all that is. There's sort of two ways to have languages interact with each other. One is through delegation, and this is script tags in HTML are sort of the canonical example of this, where the parent language sort of decides where this block of embedded stuff ends, and then we go and Lex the thing. The other way to do it is subclassing, and you can see this in C++. Over here in C++, C++, of course, is mostly C, but with some other stuff in it. Any valid C is valid C++ in a C++ file. And the way we do that is we start by subclassing the Lexer. We can override some methods that we're using to have keyword lists and things like that. We can define our own states, like what happens when you use a class, or you can use this prepend method to sort of shove new rules onto the beginning of states from the parent Lexer. So in the sort of statements state of the C Lexer, you can, for example, say now we have a class keyword, which will push this other state that we're going to use, and some other fun features that C++ has that C does not. Finally, I'm going to tell you about mixins. Look at the JavaScript Lexer. A mixin is a state that we don't ever actually potentially push. We could push it, but more or less, when you use mixin, what you're saying is at this point in the rule checking, I want to check all of these rules and do whatever they say if they match. So it's just sort of as if I copied and pasted all of these rules. There. More or less how you can think of mixins. So there are a lot of Lexers that use this, for example, for comments in whitespace, where there's like a lot of different states that have this shared behavior of how comments in whitespace work, and you can just mix that in. Of course, it's not, comments do not work inside of regexes and in JavaScript and other things. Okay, so I think that's all I'm going to cover about this DSL for right now. Everything else I'm going to show you in when we actually build a Lexer. So, workflow for building a Lexer. We're going to build a Lexer for a language called Tulip. This is a language that I invented a while back, and it did have a Lexer, but I deleted it because it was kind of out of date. But we're gonna make one that sort of works, and I'm gonna show you the kind of workflow for how you start doing it. A few years ago, a wonderful contributor whose name I have forgotten contributed this rake task. So if you've got rake going, you can run something like this, and it will generate the 4 files that you need to contribute a Lexer. So there we go. And they used this sort of weird square bracket rake syntax, which is apparently standard, but I've never seen it anywhere else before. Just that's how you do it. You put the thing in square brackets. That's the name of the language. So in our Git status here, we can see that there are 4 untracked files that this rake task generated, and these are the files needed for a Lexer. So first, we see the demos tulip file, which is currently empty. And what the demos are is they're little tiny tidbits of code that sort of show off the language to somebody. So often there's a small hello world program or 99 bottles of beer on the wall or something. So we're going to go grab some samples of tulip from the GitLab project over here. And let's use a bit of this file. So this is sort of what tulip looks like. Let's do, this has a lot of nice syntax bits in it. Cool, so there we are. There's the demo. To run the tests at this point, we're going to get some failures, which is as it should be, and there are 2. The first is we enforce that there are no error tokens yielded from any of the demos, and this is sort of a safety check to say, did we just break everything? And of course, we haven't implemented the Lexer yet, so everything is an error token. So that's fair. And the other is in the guessing spec, which it also generated for us over here in tulip spec. And this is to say, what is your file extension? Make sure that we correctly match the file extension. And for example, if you have a file that starts with user bin and tulip, it should be highlighted as tulip. These should still fail, but with less question marks now. Okay. Next important bit of that has been generated here is the sample file. Spec visual samples tulip. This is also empty. Unlike the demo, which is sort of a short snippet and should be free of errors and all perfect, this is a stress test. So you should paste in here the sort of weirdest, edge casiest bits of tulip that you can find. So let's paste that in, the stuff we had. Let's also use let's go from the tulip tests. So the hardest part sometimes is finding out what the spec is and finding these stress tests. Pigments will have them sometimes. You can go look in there. Of course, Pigments does not support tulip because tulip doesn't exist yet. Oh, there's a test macros. Right, there's this syntax that I want to implement today in our highlighter. There's some different kinds of macros. Here is a curly and some curlies are here. Okay, so we've got some special kinds of strings, we've got some kinds of tokens, etc., etc. All right, so there's a sample file. It could be bigger, but for right now, we'll call it good. In order to view this sample file, the best workflow that I've come at is using the browser. So you can say bundle exec rackup in the root of the project, and it'll start a little server that is port 9292, and visit it. We'll see a bunch of Rouge stuff. And if we scroll down here, at some point we'll start. Oh, there it is. There's Tulip, and that's how we're currently highlighting Tulip because we haven't implemented it yet. So it's all error tokens. And you can see this is /tulip here. And that's the server. A thing you should know, we're not going to be using this right now unless something goes really very wrong. But you can also pass debug equals 1 here, and it will print that familiar debug output on your terminal. So that can be good to use if you get kind of stumped. Okay, I'm actually going to run this server in a. Okay, and then lastly, we're going to look at the Lexer's tulip.rb file. And we can see it is pretty bare bones. Fill out the description, tulip programming language, .com, etc. With file names, we can associate one or more globs with our language. So TLP is our file name, and that will actually fix that one test. Analyzed text should return between 0 and 1, depending on what confidence you have that. So we can say return 1 if text.shebang. So if we got a shebang thing, and we've got our root state. So let's add some rules to the root state. So we see these kind of @ words here. Those are going to be keywords. So let's start by saying keyword. Cool. So @ and then a word is a keyword. Refresh here. Those are highlighted as keywords. Cool. Tulip identifiers are a little bit more complicated than just word characters. They've got dashes in the middle. So I'm going to have this out here and say we've got our identifiers are going to be A through Z has to be the start, and then words or dashes, any number of them. I'm using star here because I've already matched the first character. And then here I can use @ID, just regular Ruby interpolation. And you notice that I'm interpolating, and this has a flag on it. when you interpolate a regex into another regex, it wraps it with some stuff that makes it preserve all the flags. So that's fine. And this should still, yeah, that still works. S plus, remember not S star, but S plus, because we can't match empty, is the text. That should out with this. So we can see the text is, the white space is now highlighted as text. We've got a bunch of punctuation. That, what else do we see? Bang is punctuation. Square brackets are punctuation. Colon and curlies. And voila, they appear, right? So this is kind of the workflow, and we can just sort of continue with this until there are no error tokens. I want to do these sort of nesting string things, because a thing that people run into often is, how do I do arbitrarily nested data structures? So we've got this backslash identifier and an open curly. Yeah, which I'm going to put in square brackets. So that is going to be name, say, variable for right now. I don't like that much, but so there, we've got those down there. These guys are now highlighted. And then we're going to push a state. We're going to push nested string. And nested string. Let's see. If we see an open curly, that's going to be a string token. And we're going to see an open curly. There, that is going to be a string token. We're going to use the block syntax here. And then we're going to push another copy of nested string. And it turns out that this is the default behavior of push, so we could actually do that. But I'm gonna do this for clarity. We're gonna push another copy of our own state to the stack, and this is a trick to sort of easily deal with arbitrary nesting. When we see close curly, it's also going to be string token. And we're going to push, we're going to pop. And then I'm going to come back to this later, but any other character is just a string token. Yes. All right, so this is looking a little bit funny because the closed token is a string and the open token is not a string. So let's make the open token a string token. And for that, we're going to change this to use block syntax, and we're going to use matching. So regexes have matches, and there's this nice helper function here called groups, which we're going to pass name variable and string. So groups will yield tokens for groups will match each argument to the particular match group. So it'll highlight the first match as name variable and the second match as stir. Cool. So we should see immediately that open token is now that is a string. We're going to do \escapes. So / anything is stir escape. That has to go before these. So we're going to check for backslashes before we add these guys. There we are. There's our nice little \, well nested. Here's our nesting thing. Bam. And then we've also got rule that is a stir token, and we're also going to push nested string to our little hello world there. All of these error tokens on names are starting to bug me, so I'm going to add that to root. So if you see an identifier, that is a name. Those have gone away. We've got another bit of punctuation, which is the equal sign. Also counts. That goes away. There's a particular thing with the dot. So you see here these dot identifier things, which are tags, I suppose. So a dot, and I usually use square brackets instead of backslashes because it's sort of a little bit more visually obvious. Identifier. Oops. And I have to tell it what token it is. That is a name tag, I think. Yeah, okay. So we see these are working now. We've also got $sign identifiers, which I'm going to highlight as name variable. And again, for the list of tokens, there's token.rb and here. And you can also see, well, these are supposed to be highlighted. I'm going to fix this bug very soon, but you should be able to see sort of the styling of each kind of token here that you can use in whatever theme you're using. So that $sign variable is a name variable. I'm going to add a couple more things to the punctuation block. So a semicolon and a / escape. All right. And now finally there's this square bracket or angle bracket thing. And in angle brackets, there's a little bit of custom special behavior. So this is going to be name. I'm going to use this comment preproc since this is a macro feature in Tulip, so it's a little bit like a preprocessor, or at least we highlight it as such. And then we're going to say angle brackets. In angle brackets, a closed bracket is going to be comment preproc, so the same as the open one. And then when we see that, we need to pop the statement. Yeah. All right. So everything inside is an error right now because there are no more rules here. In angle brackets, you can see stars, which are punctuation. You can also see colons, which are punctuation. You can see identifiers, which are names. And then you can also see uppercase identifiers, which I'm actually going to just these to have upper ID. And if you see an uppercase ID, and notice I'm doing this before the other one, so because the other one is case insensitive, then this is a name type. Highlighted a little bit. They're not a name type. Keyword type. Or sure. Yeah, that's fine. And then there's one more error token here, which is just this backslash. Sort of after we check for this special backslash thing, then any backslash identifier is going to be a name function. It's a macro invocation. Yeah, and that's that. There's a couple of things that we haven't done, which are like numbers. But we can say, for example, 0 through 9, and then optional dot 0 through 9 plus that's optional 0 through 9. And that is a number. That's highlighted as well. There we go. That's Elixir. So we started with a bunch of error tokens. We added a bunch of stuff and sort of watched it unfold here. And now we have Elixir, and this is properly highlighted code, and it's gonna do most of the Tulip language. So I'm gonna stop there. That is all of the content that I brought. I went over by about 10 minutes, and for that I apologize. But I will open it up for questions for those of you who stuck around. And you can actually turn your audio on and ask questions if you like as well. Cool. Thank you, Drew. All right. Well, I hope that now you feel a little bit more confident in potentially going and implementing your own Lexer. There are a couple of bits of the DSL that I did not cover, but there's sort of a cheat sheet on the README here. If you scroll up, go to github.com, that's GitHub, /Jeanine/Rouge, and scroll down to about here. This shows you the Lexer DSL. There's some advanced features where you can actually just use instance variables in these rule blocks, and the context object is just the Lexer object itself. And you can call methods and things like that. But other than that, that's pretty much the basics. I went over most of it. Yeah. If there are no other questions, then I'm going to call this done. And if you have anything else, there's you can open an issue on Rouge itself. I accept pull requests. Sometimes it takes a little bit of time to get it through the review process, but it will definitely get there. And You can also hit me up on Twitter. I am Jeanine, J-N-E-E-N _, and I'll see what I can do. Thank you very much, and I will see y'all around. Bye.